In this video, we're going to apply the substitution method to solve a word problem. The question here is to find the function f of x such that the slope of the tangent line to the function is x root of x squared plus 4 for all x values, and the graph of the function f of x passes through the point 0, 3. Alright, the first thing we notice is that the slope of the tangent line is given as x root of x squared plus 4. The derivative is the slope of the tangent line. So f prime of x is equal to x root of x squared plus 4. We also know that the function passes through the point 0, 3. That means that f of 0 is equal to 3, which means when x is 0, the functional value f of x is equal to 3. Our strategy will be to integrate f prime of x, integrate a derivative to recover the function f of x. So f of x is going to be equal to integral f prime of x dx. Alright, so we're going to apply the substitution method to solve this integral. We're going to let u be equal to the inside function as usual. U is x squared plus 4. The derivative du is equal to 2x dx. Divide by 2 both sides, and we get 1/2 du is equal to x dx. So we have integral root x squared plus 4. We'll rewrite this integral in such a way to make the substitution rule easier to see, times x dx. And root x squared plus 4, this part of the integral is going to be, this part will be root u. And x dx, this part will be 1/2 du. So now we transform the integral into an integral that only involves the variable u. Integral u to the 1/2 times 1/2 du. 1/2 is a constant, passes through the integral. We get 1/2 integral u to the 1/2 du. And now reverse the power rule. We get 1/2 u to the 1/2 plus 1 is 3/2. Divide by 3 over 2, that's the same as multiplying by 2 over 3. And let's not forget to add c plus c. Let's do some simplification. The 2 cancels with the 2, and we get u 1/3 u to the 3/2 plus c. That's equal to 1/3. U is equal to x squared plus 4, returning to our original variable, to the power of 3/2 plus c. So the function f of x, this is the function we're looking for, is 1/3 x squared plus 4 to the power of 3/2 plus c. We also know that f of 0 is equal to 3. So the only thing that remains to do is to find this constant c. Alright, so we have f of x is equal to 1/3 times x squared plus 4 to the power of 3/2 plus c, and f of 0 is equal to 3. We're going to plug in x equals 0. F of x is equal to 3. So we'll replace 3, replace f of x by 3, 1/3, 0 squared plus 4 to the power of 3/2 plus c. So we get 3 is equal to 1/3, 4 to the 3/2 plus c. And now let's evaluate 4 to the 3/2. 4 to the 3/2 is the same as 4 to the 1/2 raised to the power of 3. But 4 to the 1/2 is just the square root of 4, and root of 4 is 2, so we get 2 cubed, which is 8. So 4 to the 3/2 is equal to 8. So we get 3 is equal to 1/3 times 4 to the 3/2, which is 8, plus c. Subtracting 8 over 3 from both sides, we get c is equal to 3 minus 8 over 3. Subtracting these two fractions, we get 3 goes into 1, 3 times 3 is 9, 3 goes into 3, 1 times 8 is 8, 9 minus 8 is 1, we get 1 over 3. c is equal to 1/3. So the function f of x is equal to 1/3 x squared plus 4 to the power of 3/2 plus 1/3. So what we have shown is that the solution of f prime of x is equal to x root x squared plus 4, and the function passes through 0 and 3, that means f of 0 is equal to 3, the solution of this question is given by the answer that we have here. F of x is equal to 1/3 x squared plus 4 to the 3/2 plus 1/3. All right, thanks.